Good morning, everyone. Today is Wednesday, April 12th. We are one lecture behind. So that's why I moved the quiz and homework aids from this Friday to next Monday. And please look at our schedule. How many weeks left? 1, 2, 3, 4, and then the final. Okay? And we need to cover all of these objectives. So which means you're going to be very, very busy the remaining month. Okay? So I hope this week you will use this week to submit all the missing work. So if you miss some homework, you miss some practice exam, you miss some exam correction and wrapper, please submit those this week because from next week you'll be very busy. Next week, Monday, you have homework 8 and quiz 5. Next Friday, you have homework 9 and quiz 6. And then on the Wednesday, April 26th, you have homework 10. And then on the Friday, April 28th, you have exam 3. And then the last week, you also have 2 homework and 1 quiz. Yes. So very busy. And so yeah, let's try our best. Okay. And this is the final exam is also on Monday. Okay. So let's continue. So 5.1. Yes, we haven't finished 5.1. See. Okay, so 5.1, last time we talked about exponential functions, right? And depends on the base. If the base is greater than 1, our exponential function is increasing. If our base is less than 1, then our exponential function is decreasing. And then last time we also talked about this problem, right? And so we want to use transformations. And so we first look at the parent function. This is the exponential function. Therefore, the parent function will be 2 to the x. Because the base is greater than 1, the function is increasing. So you draw this graph, and remember we have those 3 key points. So add those to your library of functions. Okay. And then don't forget to draw this horizontal asymptotes. And then we follow the same order, right? The first one, shift left or right. Hi, today we have handouts. And then because it's plus 2, so we shift to the left 2 units. And then do we have minus sign in front of x? We don't. But we have a minus sign in front of the whole thing, right? That's why we get reflection over the x-axis. So those 3 key points, yes, reflect over the x-axis. And then we see the 3 multiplied by this. So we have vertical stretch by a factor of 3. And keep the x value be the same. The y value multiplied by 3. And then finally, at 4, we shift up 4 units. So these 3 key points shift up 4 units. You also need to draw the horizontal asymptote in all the steps. Is that clear, everybody? So draw the horizontal asymptotes and also shift the horizontal asymptotes, because this problem, I will ask you, okay, where's the vertical asymptotes? Here you see no vertical asymptotes, but we have horizontal asymptote, which is the horizontal line, y equals to 4. Domain is the set of inputs, the x values. So you can see domain is from minus infinity to positive infinity. So this line is go down and go to the left. Okay, so keep going. So that's why domain is minus infinity to infinity. Range is from minus infinity to 4. You see, we're approaching to the horizontal asymptote 4, but we never touch it. Therefore, it's 4 parentheses because we don't include the endpoint. Is that okay, everybody? So in exam 3, you will have a problem like this. So put a star next to it. You will have a problem like this on the exam 3. Okay. And then, let's see. Okay. And then the exponential function with the base e. So consider the expression 1 plus 1 over x raised to the power of x. And if you plug into your calculator, if you plug in x is 1, you get, 1 plus 1, which is 2, and raised to the power 1, you get 2. Okay? And then when you plug in your x is 10, you get this 2.59 something. And when you increases the x, you get this expressions. It's getting closer to the value of 2.71828. Okay. And this function comes up in many disciplines, including finance, compounding interest, right? And the table on the right shows what happened to this expression as x growing very large. So that's why we define this number e, okay, e to be the number of this expression approaches when x goes to infinity. So this number e is often referred to the natural exponential base, exponential function, yeah, the base e. It turns out that e is irrational number, such as pi and like the square root of 2. They are irrational numbers. You know the difference between irrational numbers and rational numbers? Rational numbers is like a fraction. The numerator and denominator are integers, right? And if you look at the decimals repeat. So that is rational number. Irrational numbers is the decimal expressions, they don't repeat. So e is an irrational number. So notice that e is possibly equal to 2.71828. You see it's greater than 1, right? So therefore, e to the x, the base is greater than 1. So the exponential function e to the x is an increasing function. Okay? Last time we talked about if the base is bigger than 1, the function is increasing. If the base is between 0 and 1, then the function is decreasing. Okay, the practice I will let you to do at home. Okay, application, compound interest. You will have a problem like this in the exam, so put a big star there. So formula for the interest compounded n times per year is A equals P times 1 plus R over n raised to the power of nt, where A is the balance in the account, P is the principal, R is the annual interest rate, and n is the number of compoundings per year. So for example, if the interest rate compounded monthly, then how many months in a year? 12. If it's compounded quarterly, you have 4 quarters in a year, right, everybody? So n equals 4. So n is the number of compoundings, and t is the time in years. Okay, so how do we get this formula? All right, so let me draw on the board here. Okay, so you start with the principal, right? And let's say we just compound it once per year. Okay, so and the annual interest rate is R. Last time, in chapter 1, we talked about the interest equals the let's do the principal times the interest rate and times t. Let's say it's after 1 year. Then the interest is P times R. Right, everybody? So therefore, what's the amount of dollars in your bank? You have the principal plus the interest. Do you see it's P plus P times R after 1 year? This is the same as P. You factor out the P, you get 1 plus R. This is 1 year. Okay? So this is the first year. How about the second year? Well, second year, you have your principal, like the first year, but then the second year, you will gain another factor of 1 plus r. Yes, everybody? Because this is like your principal, like the p. And then the next year, you multiply by 1 plus r. So therefore, you get p times 1 plus r to the power of 2. Therefore, the t year, okay, the t year, instead of 2, you get 1 plus r raised to the t. Is that okay, everybody? So this is when we have compounded once per year. Now, if you compound it n times per year, then each time your interest, you divide it by n. Is that okay, everybody? Because r is the annual interest rate. But if you compound it n times per year, then each time is like the interest is then r over n. Right? And then it also raised to the power of n, because you compound it n times in that year. Is that okay, everybody? That's why we get this formula. So, yes, near the exam 3, I will also make a useful formula sheet for exam 3 for you. And then you like write down all the formulas and then make sure you memorize those. Okay? So, when n goes to infinity, this process approaches what is called the continuous compounding. And then this expression will go to p times e to the rt. Okay, why is that? Because we just said e. E is 1 plus 1 over x raised to the x goes to e when x goes to infinity. Okay, keep this in mind. Now, if you look at this expression, okay, so I call my x to be, so I let my x to be n over r. Then this is like p1 plus 1 over n over r raised to the n over r times rt. So what I'm doing, I flip it. So I express this as 1 over the reciprocal of that is n over r. And then here the exponent, I can divide it by r and multiply by r is still the same. Can you see that, everybody? So now I call this guy x, and I call this guy x. Now, do you see here, this is p1 plus 1 over x to the x and times rt? Yeah? So now, this is e. Therefore, we get this formula, p times e to the rt. Okay? So when the n goes to infinity, when n goes to infinity and r is fixed, so your x also goes to infinity. Yes, everybody? So that's why we get, for continuous compounding, the formula is p times e to the rx. So can I erase this? Or maybe, okay, I can wait a little bit. Okay, so e to the rt. So t is the independent variable. If r is greater than 0, so r is the interest rate. If it's greater than 0, then we have like e to the, for example, if r is 3, you get e to the 3t, then you will have a increasing function. Domain minus infinity to infinity, range is from 0 to infinity, and it's always increasing. And it has a y-intercept at 0, 1. And we have a horizontal asymptote at y equals to 0. Yes, everybody? If r is negative, for example, if r is negative 3, then we have e to the negative 3t. You can express this as e to the negative 3 to the t. This is like 1 over e cubed to the t. Now, do you see this is like our base? Our base is less than 1. Yes, everybody? Our base is less than 1. That's why our exponential function is decreasing. Okay. So e to the RT, if R is greater than 0, you have an increasing exponential function. If R is negative, then you have a decreasing exponential function. Domain still the same, minus infinity to infinity, range from 0 to infinity. And the y-intercept is the same. The only difference is one is increasing, one is decreasing. Is that clear, everybody? All right. So example. Okay. Yes. So for example, let's do it together. Okay. So for sure you will have a problem like this in exam 3. Okay. So put a star there. You invest $12,000 at an annual interest rate of 3%. So $12,000 is the principal. You put the P there. 3% is what? The annual interest rate, which is point what? 3% is point, yes, 0.3. Find the balance after 5 years. So T is 5 years. When the interest is compounded quarterly. What's quarterly means? How many quarters in a year? 4. Good. Right, everybody? So you, yes, quarter, 4. Then we put in the formula. Okay? What is the formula? Okay, A, the amount in the accounts equals principal times 1 plus annual interest rates divided by n raised to the power of NT. So this is the formula. Okay, make sure you memorize this formula. Then we just plug in a number. What is P? 12,000. What is R? Yeah, 0.03. Let's see. 0.0. Something wrong with my pen. Hey, it does not allow me to write on it. Okay, 0.0. What's wrong? 0.03 divided by n. What's n? 4 to the n. 4. What's t? 5. Okay, everybody, put this in your calculator. Everybody, you need to know how to use your calculator. So all of you take out your calculator. Type this in one line. So you put 12,000 parentheses. 1 plus 0.03 divided by 4 parentheses raised to the power of, what's that? 20. Everybody put that in your calculator. Oh, so make sure on the exam you bring scientific calculator. Okay? Yeah. What did you get? So 12,000. And then times parentheses. 1 plus 0.03 divided by 4. No, before the parentheses divided by 4. And then parentheses raised to the power of x. 1. Okay. You get that? You get that? Okay. So tell me, what do you get? What? 13,934.2. Give me 2 decimal places. 1. Okay. Percent, right? So 2 decimal places. Okay. Yes. Do you have the same answer?
Yeah.
Yeah.
What I did, I put an extra parentheses for 0.3, 0.03.
Oh.
That way it wouldn't get confused with the 1. Like that way when it reads in the calculator, it doesn't read 1 plus 0.03 over 4.
Oh.
So just read. So then it calculates the fraction and then it calculates the addition.
Oh.
You get it?
Okay.
But I mean.
You did get the same number?
No, we got a different answer.
Then probably the parentheses will. Did? Because it's 1200, it's not 1200. Yeah. Okay, that is part A. Part B. How many months in a year? 12. So you plug in what? P is still the same. And now your N is 12. So raised to 12 times T, which is 5. So your calculator, you don't need to retype the whole thing again. Go up to the previous line. Change the 4 to 12. Do you know how to do it? Go up to the previous line. Yes, change the 4 to 12. Do you have the previous line? So type it again. Oh, no. Oh, you do that? Okay. Yeah, enter. So.
Because we're also changing it from the high school.
Oh, it's 4.5, not 4 times 5.
It's 60.
So you put 20. Oh.
Yay.
So, raise. This is the button. Raise to the power. You put 20. And you get that answer. Okay. So what number do you get? Thank you. Okay, everybody. So that is monthly. Now part C. When you see continuously, you use different formula. You use the one with the E. So the formula is P times E to the RT. Right, everybody? Okay. And you can see here, this formula, it has no N in it. The N is like go to infinity. We have the number of compoundings go to infinity. So you compound it like every second. Okay, so P is 12,000. E to the R, what is R?
0.03.
Yeah, times T, 5. Okay, everybody type this in your calculator. Can you find the E in your calculator? Yes, type that in your calculator. What did you get? Yes.
It's going to be 0.03 times.
E. So it's up there. So you press second and then the LN give you the E. Everybody see the E? You press second and press the bottom LN. That's the E. Yes, do you get that? Everybody? What number do you get? 139. Thank you. So in the exam, you will have a problem like this. Okay, everybody? Know how to do this problem? Okay, good. Wow. We used 25 minutes on 5.1. Now we need to go to 5.2. Okay, so let's go to 5.2. Yes, 5.2, which is a new handout. Okay. All right, so 5.1, we introduce exponential function. The 5.2, we're going to talk about the logarithmic functions. So motivation. Try to solve the following equations twice. So here, we have multiplication. To solve for x, what do? Divide by 3. So x is 3 divided by 5. Divided by 5, not 3. So this is multiplication. But to solve x, we introduce division, right? How about here? This is a square root of x. To get rid of the square root, you square both sides. And what is 2 squared? 4. How about cube roots? How do you get rid of the cube roots? Cube, right? Cube. So you get x is 4 cube. 4 cube is 4 times 4 is 16. 16 times 4, 64. Very good. Okay. Now, how do we solve exponential so equation involving exponential expressions? Well, we want to get rid of the 2, right? So therefore, this one, in order to solve this, okay, we want to undo the exponential function. In other words, we want to find the inverse of the exponential function. Okay, so I can tell you the answer right now, and I will talk about what it means. Okay, so the answer is x is log base 2 of 7. Okay, so I will talk about what it means. So we want to undo the exponential function. So we want to find the inverse of the exponential function. So you know this is b to the x, right? Everybody, we just learned it is an increasing function, looks like that, right? And how do we find the inverse? First of all, this function is 1 to 1, right? Because you use horizontal line to intercept it, you only get 1 point. So it's 1 to 1. Okay, so it's 1 to 1. Therefore, it's invertible. The inverse exists. Okay, invertible means the inverse exists. Okay, so how do we find the inverse? Well, remember, we draw the line y equals x, and then we find the mirror image. So mirror image like this point. Okay, the mirror image is here, right? Like this point, mirror image is here. Like this point, mirror image is here. Like this point, just pick some point and then you find the mirror image. And then you connect those points together. You get this graph is the inverse function. Is that okay, everybody? Mm-hmm. Yes. So now let's try to find the inverse algebraically. So you have y equals b to the x. X is the input and y is the output. Right, everybody? Now let's introduce the logarithmic function. We introduce the logarithmic function. So log b of x. Now b is still the base. You see, the b is the base, so the base is still the same. Okay, so you put the log and you put the b on the right hand side. So this is the base. Now x is gonna be because this is the inverse function, so x is like the y and the y is like the x. Because inverse function, you kind of switch the x and y. Okay, So therefore here, suppose b, the base, is greater than 0 and the base is not 1. We define the inverse function to be log b of x. And this is a logarithmic base b of x. Key property, log b of a equal to c if and only if, see, the base is still the same. So you put the b here, that's the base. And then here it was the input, now it becomes the output. C is the output, now becomes the input. So you kind of switch the input and output position. Is that okay, everybody? Or, so this is called a logarithmic form, and this is called an exponential form. Or you can think of this way, okay? So you can think of this way, because log and exponential function, they are inverse function, okay? They're inverse function. That means log b, b to the x is x, because they are inverse function. You apply the exponential function first, and then you apply the log, they kind of cancel. Okay? So log b to the x, they kind of cancel, you get x back. And also b to the log b of x, the b and the log b also cancel, you also get the x back, because they are inverse function. Okay? So inverse functions property. Okay. Now, the b any base greater than 0 and it's not 1. But in your calculator, there are two kind of common logs. The first one is the base 10. Look at your calculator. Do you see log? That means the base is 10. Do you see ln? That means the base is e. Okay, everybody? So in your calculator, you only have those two kinds. Let's do. And from now on, let's use the natural log, because you will see this a lot. So base is y. Here the base is 10. Okay. All right. So example 1. Evaluate the following log. Okay. So how do we do? So remember log b to the x is x, and b to the log b of x is x. Okay, so therefore 8, what is 8? 8 is 2 to the third. Yes, everybody? See, you have the same base, log 2, they cancel, you get x, which is 3. Yeah, we're using this property. Log b and b, the inverse function, they cancel. You only get the x back. So log 2 cancel. You only get the 3 here. Is that okay, everybody? Similarly here, we want to express 64 as using the base 8. What's 64? It's 8 square. Very good. So what is log 8? 8 square? 2. Yeah, awesome. Okay, how about log 6? 1. Okay, what is 1? Everything to the 0 is 1. Do you know that? So we can express 1 as 6 to the 0. So you get 0. Good. Okay, so the ABC, we can use this method. Part D, let's use different way. Okay, I'm teaching you a different method now for part D. Because your base, you see your base is 1/2, it's not so obvious. Then what do? Okay, so you set this guy equals to x. And this is the logarithmic form. and you want to change to exponential form. How do you do that? Okay, tell me what's the base. 1/2. You see, your base is 1/2. So you change to the exponential form. Your base is 1/2, right? And then you have your output and you have your input. Look at the log form. 4 is the input or output. In the log, it was the inputs, right? And then in the exponential form, you want to put it in the input or outputs. In the outputs, right? The 4 was in the input of the log. And then when you put it in the exponential form, you want to put it in the outputs. Yes? So we put the 4 here. And then this x, it was the input or outputs. It was the output. And then when you put it here, you put it in the inputs. Very good. Okay, so the log form and the exponential form, we kind of switch the input and outputs. Okay, see, now this is something we learned before. Okay, so 2, 1/2 is 2 to the minus 1. Do you agree? Yes, we change to the base 2. 4 is what? 2 square, right? Okay, on the left hand side, what do you do to the exponents? Do you add them or you multiply them? What's the exponent rule? If you have a to the m times a to the n, what do you do to the exponent? You add them. But if you have a to the m raised to the power of n, what do? Multiply them. So here we multiply them. Minus 1 times x. Yes? Now, do you see both sides? We have the same base. Last time we said if we have the same base, just set the exponents equal to each other, right? So we got negative x equals to 2. What is x? X is negative 2. Okay, so this log half of 4 is negative 2. Questions? Oh, sure. Okay, 1/2 is 2 to the minus 1. 4 is 2 squared. So you want to express both sides with the same base. See here, your base is 1/2. They're not the same. You want to express with the same base. That's why we pick the 2. So 1/2 is 2 to the minus 1. 4 is 2 squared. And then, okay, we want to figure out what is this. So 2 to the minus 1 to the x, you multiply the exponent. So you get 2 to the minus x. So therefore, now both sides have the same base. You set the exponent equal to each other. Yeah. Okay, let's do this one using this method. So we call this x. What is the base? 1/3 is the base. 27 is the base. So you put 27 is the base, and what do you put on the exponent? X. Yes, everybody? So x. And then where do you put the 1/3? Yeah, output. Okay. Do you see both sides? They don't have the same base. You want to express as the same base. Then what is 27? 3 cubed. Yes, 3 cubed. So 3 cubed to the x equals, what is 1/3? Yes. What do you do to the left? Multiply together. Now, Do you see they have the same base? Yes. So, yeah, 3x equals 1 minus 1. And x is, yeah, very good. So this log 27 of 1/3 is negative 1/3. Is that okay, everybody? So I teach you two methods. The method 1 is when your base is easy. The method 2 is when your base is not easy. Okay, everybody? How about part F? Tell me, the base is easy or not? 7 is a prime number, so it's easy. Yes. The 27 is factory cube, so it's more expressed as an easier base, right? But 7 is kind of easy. So we use method 1.
So wait, when we're finding x, we just forget if the bases are the same, we just completely forget about them?
Yes. This is what we learned last time. If you have the same base, you just set the exponent equal to each other. Yeah. Okay, so now we use method 1. So log 7. What is 49? 7 square, right? And then what is cube root? You raise the power of 1/3. Oh. So what do you do to the exponent? It's 7 square and then to the 1/3. Yeah, multiply. We get 2/3. So what is that? 2/3, exactly. See? So you get the log 7 and 7, they cancel, you just get 2/3. Okay. All right. Any questions about example 1? All good? All right. So, yes. Okay, now we call the exponential function. So this is the exponential function, right? And then I just show you, we draw the line y equals x, and then find the mirror image, then connect those points together, you get the graph of the log. Yes. So based on the exponential function, you can draw the graph of the log. So this picture is when the base, is greater than 1. And you can see the domain, it was minus infinity to infinity, and now it becomes the range. So the domain of f is now the range of the f inverse. Yeah, so you put this down here. And the range, it was 0 to infinity. Now it becomes the domain. Yes, you see that? The range now becomes the domain of the inverse function. So now the domain is 0 to infinity. And do you see it's still increasing? So still increasing on 0 to infinity. Do we have horizontal asymptote? Do we have horizontal asymptote? No. But, sorry, we're talking about intercept first. Do we have y-intercept? No, it's approaching to it, it never touched. So no y-intercept. But we have an x-intercept, which is this point. See, this point, it was the y-intercept of the exponential function. Then the mirror image becomes the x-intercept of the logarithmic function. And this point is 1, 0. Okay? And asymptote, we have vertical asymptote. So this is x equal to 0, but we don't have any horizontal asymptotes. Okay, everybody? So if you remember the graph of the exponential function, then you can find the graph of the logarithmic function. Okay, everybody? Similarly, okay, so we get a bigger list of our domain. Do you remember what are the functions with restricted domain? The first one, it was square root of a, yeah? You need the a to be greater or equal to 0. And then second one, we have the fractions. you need the denominator not equal to 0. Now, add one more. Add the ln of a. Because it's not only ln, it could be any base, so log b of a. But usually we use ln a lot. So just put ln of a. Then we need the a to be positive. Okay, so because the domain of the ln of x, the log, any log base, okay, the domain is positive. That's why we need the things inside the log to be greater than 0. So now we have 3 cases, right? 3 expressions with restricted domain. Okay. So yeah, in the exam 3, you will have a problem like that to find the domain. And then you'll see some law expression. Okay, keep going. How about when the base b is between 0 and 1? Okay, when it's between 0 and 1, we know this is a decreasing function. Yes, it's a decreasing function. So what do? Let's pick these 3 points. And you see this point, you get mapped here, and this point get mapped there, and then this point get mapped here, and then you connect those 3 points, you get the graph of the log. And so it's going down. Okay? And your domain is now the range of f, right? So it's still 0 to infinity. Range, bless you, is the domain of f, so minus infinity to infinity. And do you see it's decreasing all the time? So you put decreasing on 0 to infinity. Do we have y-intercepts? No. Do we have x-intercepts? Yes. So the point 1, 0 is the x-intercept. Do we have vertical asymptote? Vertical asymptotes. Yes, that is the line x equal to 0. Do we have horizontal asymptotes? No. So no horizontal asymptotes. Okay. So now you know the graph of exponential function, and then you also know the graph of the logarithmic functions. Okay. So let's see. Keep going. Okay. Let's do example 2. Okay. Example 2. Find the domain of each function. So domain, when you see ln, you need the things inside the ln to be greater than 0. See? Now it becomes to solve inequality. So far, so good, everybody? All right. Can we factor? So 9 minus x squared. Can you factor? Very good. 3 plus x and 3 minus x. And what are the critical numbers? So you set 3 minus x equal to 0, and you set 3 plus x equal to 0. What is x? 3 and negative 3. Okay. Now remember, the real number line, we plot those critical number. Tell me, open circle or solid circle? Open. Okay, what is the leading coefficient? Is what? 9? Is this a leading coefficient? 1 or minus 1? Minus 1. Then you start from the top or bottom? Bottom. Okay. When you go to 3, 3 corresponds to 3 minus x. What's the multiplicity? 1. So we cross or bounce off? Cross. How about negative 3? Cross. And this is plus, this is minus. We are looking for positive or negative? Positive. See this piece. So what is the interval notation? 2, 3, exactly. So this is the domain. Okay, yeah, let's continue on Friday. Have a nice day.